Well, good morning, guys. Today I'm going to talk to you about scale. And scale is one of my favorite concepts in science because it helps us think about things that are way bigger, way older, and way smaller than ourselves. So, if I asked you to measure from your house to Las Montañas, which tool would you want to use? Which measurement would you prefer? Centimeters, inches, miles, yards, kilometers? So probably nobody's picking centimeters, right? Because it would be really hard if you had a centimeter long ruler, or an inch long ruler to measure from your house to Las Montañas. A couple of you live really close to the school, like in this neighborhood, and so you might be able to do it in yards. But for most people, we'd rather measure it in miles or kilometers because it's far enough away that that tool would make more sense. Okay, let's say you were traveling from here, New Mexico, all the way to Argentina. Would you want to walk there, bike there, fly there, ride a train, or drive there? Probably you're gonna pick something like flying because that would take the least amount of time. So if you were gonna walk there, which I'm sure somebody could do like to raise money or something, but if you were gonna walk there, it would take a really long time, like several years to walk there. But in flying, we could get there in less than a day, so that would be way better of a way to travel there. Okay, these questions, when I ask students to do this in class, they get so mad. So I give students a little piece of yarn that is a yard long and ask them to measure their foot with it. How long is your foot in yards? And it's really frustrating, and students get really mad. Sometimes I give them a centimeter long piece of yarn, so it's really, really short, and ask them to measure across the whole classroom. And instead of actually doing it, students just get really mad and they tell me that it's dumb and I shouldn't ask them to do something like that. And that's why we need different measurement tools, because it is dumb to try to measure across a classroom in centimeters because there's a way better tool for that. So here's just another example. If I asked you how many microseconds you slept last night, just so you know, here's a microsecond. And microseconds, there's 1 million of them in 1 second. So if you were going to count that many microseconds of your sleep, you'd actually probably die before you could ever count that much. So it doesn't make sense to do that. That's why we need scale. Measurement in science is a really big deal, and we have a lot of really innovative ways to measure things. So let's talk about this cool website really quick because I just want to zoom in and kind of give you an idea of how small and how big we're talking when we discuss the universe. So this is a really cool website called The Scale of the Universe. If you want to look it up, The Scale of the Universe, you can zoom in and out of it, and it's really awesome. And we're going to zoom in and we're going to see the smallest things that we can measure, and we're going to zoom out and see the biggest things that we can measure. So it starts out, and this circle is 1 meter. Every time we get, like we're going to go find another circle really quick. So here is a millimeter in diameter circle. So it's showing you like an ant is maybe like 2 millimeters long. But this pollen that will give you allergies is, I think that's pollen, I can't remember. Let's click on it and find out. Oh no, water lentils. So they float in bodies of water and they make flowers, and they're the tiniest plant or the tiniest flowers of any plant on earth. So how cute. So we could keep zooming in, and I'm going to do that. I'm going to just zoom all the way in. So here's the size of DNA. So if we go back out and we look at an ant, compared to an ant, DNA is super tiny, like it's not visible. Even ants, even though they're way smaller than us, they cannot see DNA. So we keep zooming in. Okay, we get to the hydrogen atom and the helium atom. These are different types of wavelengths. So this one right here is a gamma wave. Gamma waves are so small, the reason that they harm your body if you interact with them is they can like tear apart some of the atoms and like the cells in your body, and that makes you really sick. Okay, if we keep zooming in, we get a nucleus size. So nuclei are really small compared to atoms. Keep zooming in, we get quarks, which make up protons and neutrons, neutrinos. we get different types of neutrinos. And if we keep zooming all the way down, okay, we get the quantum foam, the length called Planck length. This is a measurement tool. And the string of string theory. This is 10 to the negative 35 in scientific notation, or other words, if there was a decimal right here between the 1 and the 0, we would have to move it this way 35 times and then fill in zeros in front of it to get to this size of a meter. So it would be like 0.000000035 times of 1 meter. Okay, let's zoom the other way now. See if I could pull this out faster using this part. I don't want to keep going too much. Alrighty, here we go, here we go. Okay, so back to our normal size of understanding. Okay, we are about this big, so the things that we understand really nicely are about this big. Like I look at hummingbirds in my yard and I think, oh my gosh, they're so tiny. Look at their little tiny feet. And they look small to me, but remember, there's way smaller things compared to a hummingbird. If we zoom all the way out, okay, this is the diameter of this circle is a kilometer, so you can see how big these are. Okay, keep going. We're going to get to a megameter. So Texas is really big, but they're not as big as Alaska, even though they want you to believe that. All right, let's keep going. Stars. We get to stars. Red giant stars, and then we start getting to the nebula size. The Kuiper belt is actually like the size of our universe, kind of. Well, the Oort cloud is, but the Oort cloud is really, really hard to detect. So here's the Oort cloud. That's basically the size of our solar system, the very edges of our solar system. Then we get to these other nebula, which are big clouds of gas in which stars can form. They're left over from supernovas. Then we're going to start getting to galaxy size. So we live in the Milky Way galaxy, which is represented right here, and our Andromeda galaxy is our neighbor. So we can keep going bigger than galaxies. There's even structures in the universe like the Sloan Great Wall, which is this high density of stars right here. And then we get all the way to the observable universe. Okay, so this is the estimated size of the universe. And so things are really big and really small compared to each other. Things are really old and really young compared to each other. And that's what scale is all about. Okay. Scale helps you think beyond your own experience. So this is a woman named Hester Ford. She just, I think like yesterday or the day before, turned 116. She's very, very old. I think she's the oldest person in the United States. Now, that's really old to me, 116 years. Like, I don't plan to live that long. But that is not very old compared to the Earth, which is billions of years. Okay, these are these tiny little bugs called springtails, which most people don't even notice them, but I do because I'm hypersensitive to everything. And they live like basically everywhere. Like you've got them in your house, they're in your yard, they're in the school, they're everywhere. And they are super, super tiny. But compared to DNA, they're very huge. So it helps you when you're thinking about scale and the different size of things. You're not just thinking about if something is big or small anymore. You're thinking about is something big or small compared to something else. This is just to illustrate how much trillions and billions are. So things in outer space are trillions of miles away from us. And so I want you to understand how big is a trillion or how many is a trillion. So this is $10,000 here, a nice wad of cash. I would take it. If anybody wants to share $10,000 with me, I'll take it. Okay, this is actually $1 million right here. This little tiny stack of $100 bills would actually be $1 million. And then 100 million would be a whole pallet of money. $1 billion would be 10 pallets of money. And if we get to $1 trillion, it would be this many. So this is showing you that it's zoomed in right here. This is that little dude standing next to $1 trillion. It's an insane amount that's hard for us to understand because I mean, I can just safely say I don't think any of us will ever have $1 trillion. Okay, here's another way to think about scale. It's a way to zoom in or out to study something. So in biology, we have a drop of pond water, and we could consider that an ecosystem because it has biotic and abiotic factors. It's got living things, consumers that are going around eating, producers that are making energy from light. And so we could consider this an ecosystem. But when we talk about the Chihuahuan Desert, It's the largest desert in North America. And we would be talking about this whole space that goes into New Mexico and comes down into Mexico. It's named after Chihuahua, which is the state right on the other side of us. Um, so this is a way bigger ecosystem. So sometimes we think about just a teeny little one that we can only see on a microscope, if that's what we're studying. And sometimes we're studying the boundaries of this like international desert area. So the creatures in here, they don't care about the line of Texas and um, Mexico. They just know that this is the places where they like to live and grow. So that's kind of cool that we can think about something so big as an ecosystem or something so small. It just depends on what we're trying to study. Okay, so if I told you the radius of the Earth and the radius of the Moon, which I have listed them right here, okay, that doesn't really like make very much sense to me. Like I'm like, okay, well, I know like some people run a kilometer, or a 5K, so it's like it's pretty big, the radius of the Earth. But if I show you the Earth compared to the Moon in like a picture like this, the Moon fits across the um the Earth about 4 times. That's how small it is compared to the Earth. So when you measure something by comparing it to something that you understand already, it makes a lot more sense. That's all. Have a good day.